I want to continue to show you this model that we're working on. So, if you remember, we created a Gssha model for this area, and part of this Gssha model is we got the depths. So here's the depths. So I ran the Gssha model, read it in. Here are the depths in the watershed. Here's my hydrograph. And so there's a lot of different information that Gssha computes. One of the things, so there are a couple of things I want to talk about. One thing I want to talk about is how, if I have several different scenarios, how would I model those different scenarios in Gssha? So, for example, if I were planning on changing some of the land use types in this watershed, I could define a polygon. So I can go here to the land use coverage. Let's just change some of the land use in this watershed. So we'll define a polygon and change this land use maybe in this area. Maybe there's a new development or something, or a new residential area that's being built here. We'll build that polygon. Actually, before I do that, let me delete that poly. So the first thing I'll do is I'll copy this, duplicate this coverage, this land use coverage, and I'll rename this coverage to be this will be the developed land use. So if I want to change this land use, I could create a new land use coverage and then go in and create a polygon. So this is my new development here. And I'm going to build my polygons. In that polygon, let's assign the residential land use to it. So let's say this is land ID 11. Maybe that's residential. And so I've changed that land use. So if I go to the Gssha, the 2D grid module, and then go to the map tables, the land use could affect my infiltration rate. So here I have land ID 11. I'm just using the same infiltration parameters for all my different soil types. But let's say with a land use change, maybe my hydraulic conductivity will decrease if I change the land use in this area. So wherever I have land use ID 11, I can go in and change this to have hydraulic conductivity of 0.1. Okay. Then I can create a new model. So we'll create a new Gssha model, add new Gssha model here. And this model will will define some new information. So we'll call this model whoops. So let's say we're going to make this new area. We'll call this post development. We're going to develop a new area. So this will be our post development model. The job control will be the same. The precipitation will be the same. The Gssha coverage will be the same. The index maps, I need to assign index maps. So let's create a new index map from this developed land use coverage. So I'm going to go to the Gssha menu, select maps, and there's an option. So here we'll use the developed coverage to create a new index map. So we'll call this new land use. And so that'll include this new area of development that I have. And then, so we have that new index map. Also, I would probably want to create a new combined index map. So I'll do the same thing, go to Gssha, maps, and use the land use, the developed land use map, and then the soil type map, and we'll call this new combined. Okay, so I'm going to use this new land use and the new combined index maps for this post-development scenario. So this is a new scenario that I'm trying to model. The other thing I'm going to do is we're going to assign the existing soil texture index map to this model. Then I'll right-click on this model, go to the mapping tables. Right now the model doesn't have any mapping tables because I created some new index maps. So we're going to use the new land use map, and we're going to define our roughness values. I'm just going to use the same roughness values here for each of my land use types. And then we'll define some infiltration parameters. So we're going to use the new combined infiltration parameters. I'm going to save this table from my other model here. What's that?
Did we export the image table before?
I haven't exported it, no. So I'm going to go here to my other model and export this table. Then I'm going to read it into my new model. We'll just import this new table. This one. So then all those parameters are defined for my new index maps. I still need to define my initial moisture. And so this value, I was just using the field capacity. I could re-import my table after defining that, but I'll just use this. Okay, then I could run, there's an option, so if I have multiple scenarios, there's an option to run all these scenarios together as a Gssha group. First, let's save this group. So we'll save both of these. We'll find a file name for the group. So I'll call this Park City group. And then WMS will save this file out, those files out. Then I can, if I want, I can run both of these models together. I can run just this new model. So I can run Gssha on this model. It says I have an error. Oh, I need to define my precipitation. So we'll go to the precipitation here. Actually, what I should have done, I should have done this when I first started. I should have just duplicated this model, this demo model, instead of creating a new model. So when I created a new model, it didn't copy the information from my original model. But so let's just use this same information. So 59 millimeters. And we'll define the same distribution. And we'll try running that again. Okay, so it ran. WMS will read in the solution. So it looks like I don't get flow for some reason. Not sure why. But anyway, so that's how you do scenarios. Let's go and run this original. Let's go back to this original model. I'm just going to duplicate this model. I know that this model runs. And let's see what happens if I put a detention basin. Let's figure out how to put a detention basin in this model. So I'll rename this model, call this detention basin. I'm actually going to run this, well, we'll run it later. Let's delete this model that I had created. So this is my model. I'm going to model a detention basin. The way you model a detention basin is that there are a couple of steps. So the first step is you go to the Gssha coverage. So here's the Gssha coverage. And since this is I can duplicate this Gssha coverage, so I'm going to go ahead and duplicate this Gssha coverage so I can keep my original coverage the same. And then we're going to call this new coverage, this will be the detention basin. Call it Gssha DB for detention basin. And we'll assign that, you can assign that coverage to this new model that I had created. And so now this is using the Gssha detention basin coverage. Then I can go in and define detention basin parameters. So I can go here to my, wherever I want to create a detention basin. Let's create one. You create a node wherever you want one. So I'm going to create one right here. I'll create a node at this location. Go to the point attributes. Then there's this hydraulic structures option. One of the hydraulic structures options is to create a detention basin at this location. And for your detention basin, there are several parameters that you need to define. The minimum water surface elevation, the initial water surface elevation, and the maximum water surface elevation. And so let's define those parameters. So let's look here at the elevations around here. The elevations are around 2155, maybe be the minimum. 2190 maybe is the initial, and 2220 or something is the maximum. Let's try. So I can define those parameters for this detention basin. Do you remember what they were? So this elevation is 2150. $21.60 will be my minimum. My initial is 21.90. My maximum will do 22.20. Then there are some other options. You can define a rating curve for this detention basin, but you do not have to do that. So WMS or Gssha, when you run Gssha, it's going to compute a rating curve from my grid elevations. The other thing that I want to do is I want to create some way for water. So I could do this rating curve. I want to create some way for water to get out of this detention basin. So usually what you'll do is you'll define a weir for this detention basin and maybe a culvert or a scheduled discharge. There are different options for the detention basin. So let's define the weir length. We'll say we have a weir of 5 meters. You can define some discharge coefficients and the crest low point elevation. So that's the elevation of your weir, and let's say it's at 2190. Let's say. So I've done that. The other thing I need to do when I create a detention basin at a location, I need to create an embankment arc that represents my detention basin embankment. So I'll just draw a line here in front of this outlet point, or this detention basin. And you don't want this line to intersect this stream arc, so I'm going to try not to intersect that stream arc. And maybe my embankment looks like something like this. Then what I would do is go to the, there's an option to edit the elevations. You edit the elevations for this embankment. So I can go to the arc attributes, change this to embankment, and I can go here and set the elevation. So let's say the embankment is at 2220 meters. So I'll just offset. So there's my embankment. And so WMS just uses these are the grid cells here. This is the top of the embankment. You can use the offset arc, or you can compute, there are different options to compute the embankment. And then what WMS does when I define that embankment, WMS will draw these red cells, so they're kind of hard to see. But these red cell boundaries right here, that's where those are used in Gssha to represent my embankment. And so I've defined my detention basin, I've defined my embankment, that's this arc. Then I can run my detention basin. So let's go ahead and run. Oh, the other thing I want to do is I want to check my lake elevation. So you can turn on these lake cells, the minimum area, initial area, and maximum area. And WMS will show you what the lake looks like. So it looks like actually the lake overflows this embankment. So maybe I need to extend my embankment out a little bit farther, or change how my embankment is, where my embankment is located. So let's I'm just going to change a couple of things. I'm going to move this over here. Move this over here. Then we'll look at the elevations. So the elevations are still okay. And then, so after you do that, you have to recompute update your lake cells. So you go here to Gssha, update lake cells, and you just don't want the lake to overflow your embankment, I guess. So this all looks good. This is my detention basin. And then I can go ahead and run Gssha with this. So I'll go to right click on this, run Gssha, and we'll run it with this detention basin. And the detention basin, actually, the Gssha models, if you have a detention basin or lake cells, Gssha will take a little bit longer to run. And it could be a lot longer depending on how big your model is. But we can just see how this detention basin impacts my hydrograph and different things. So we'll read the solution here, and you'll be able to see the depths. Let me turn off the lake cells. So here's my depths as I go through this model. And I don't really get any rainfall until kind of later in the simulation. And actually you're probably not going to see the contours from the rainfall because most of the depth, the deepest part, is where this lake is located. You can also, there are different options. So for scenario modeling, here's my hydrograph at the outlet. This hydrograph is a lot lower than the hydrograph without the detention basin. But if I want to run all these models together, I can just run this whole Gssha group and read all the solutions. I could do that. It's just, WMS is just going to run both of these models one after the other. And if I have several different scenarios, I can run all those different scenarios all at once. And so that's kind of what I wanted to talk about. Trying to think if there's anything else that we discussed that we haven't already talked about. So we talked about infiltration. Let's look at some of these advanced topics. We're going to talk about long-term simulation later. We haven't discussed wetlands. I can show you how to add a wetland to your Gssha model. We know how to do reservoirs, so I showed you how to do reservoirs. You add your reservoir at a point in your model, and then you add your embankment for that reservoir. Long-term simulations we're going to talk about. Groundwater, I think we're going to talk about that. Wetlands, we'll talk about. Sediment transport, we have some other stuff to talk about with that. And then storm and tile drains. So, I don't know, is anybody interested in doing storm and tile drains with Gssha? Or storm drains? You know about tile drains? You know what a tile drain is? So they're used in farming usually, and they're used to drain soil. So it's an underground pipe with perforations in the pipe that's used to keep the soil so it's not too swampy. That's a tile drain. And so the water goes into the pipe, the groundwater goes into the pipe and drains out the pipe. Do you have tile drains? Okay.
But can you use it to design tile drain, or?
Yeah, you can use it to design tile drains. You can also use it just for storm drains. So if you're doing storm drain design, you can use it for that. So let's look at, so Gssha ran these two models, and it read the hydrographs, or WMS ran our two models and read the hydrographs. Here's the results of the original model right here. Here's the depths. And here's the results of the detention basin model. Here's the depths. If you want to add a wetland, you can do kind of the same thing. I mean, you copy this original Gssha coverage. So I would duplicate this. We'll call this Gssha wetlands. And for the wetlands, to create a wetland, you just define a polygon that represents your wetland. So let's say this area here is where I want my wetland, so I define a polygon in this area. Oops. I guess I snapped to one of the arcs. Let's delete that. Define a polygon that represents my wetland. And then I can build that polygon. So I'll select it, right click, build polygons. Then I can go to the polygon attribute. So select this, select polygon, go to the attributes, and assign that to be a wetland. Then there's some wetland parameters. So let's say I initially have maybe 10 millimeters of storage in my wetland. And then there are different parameters. Retention depth is the depth of the water in the wetland that will not be routed, except it's going to go into groundwater. So let's say retention depth is, I always want 5 millimeters in my wetland. Hydraulic conductivity for the retention depth, let's say it's 0.5 meters per day is the units. Vegetation height, let's say it's 100 millimeters. The vegetation height, hydraulic conductivity, that's the hydraulic conductivity when the depth is above the retention depth and below the vegetation height. Let's say it's a little bit higher, so we're going to say 1 meter per day. And then the inundated Manning's roughness value. So we're going to say 0.2. You find all that, then you can run that wetland in Gssha. And when I run it, now I'll probably want to create a new scenario, so I'll duplicate my original Gssha model. Duplicate, and we'll rename this to wetland. And we will use, in this, we'll use the Gssha wetlands coverage. And we'll use all the same other parameters. And I can run that model and just see what the results are. Okay. So that's how to do scenario modeling and how to do wetlands, detention basins.
The run that you put for the webcam, is it possible to get from any resources on the website?
For what?
The parameter you put.
The parameter for wetlands? Okay. So the parameters for wetlands, there's really, we do have, I think I gave you a slide maybe that talks about wetlands. Let's look. Maybe in this one we talk about wetlands. Okay, yeah, we don't, so I didn't give you some starting values. Yeah, so I think the Gssha Wiki website does have some values for wetlands. So let's look. We'll go to gssawiki.com, wetlands. And we'll go to the wetlands setup. Okay, I guess it talks about what each of the parameters mean. There might be another page that talks about how to set up, maybe this one. Some initial values for wetland. Let's look here. Yeah, I thought there was a page on the Gssha Wiki, and there may be one, but I can't find it. I thought there was a page that had some values, some possible values for the wetland parameters. But, so your retention depth, I mean, you just kind of have to know what they are. This picture is a good picture, shows you what all the parameters are. Because you're going to enter the vegetation height, you're going to enter the retention depth, you're going to enter the retention hydraulic conductivity, and the
But there is no additional values.
yeah, I don't,
Like, is there a classification over the wood or over the blue about the wetlands? Like this.
there probably is, but I don't, just off the top of my head, I don't know where it is. I mean, I'd have to look some more to find out those values. And you could probably find them too, but I think there might be something on the Gssha Wiki, but I don't know where it is. I have to search around a little more to find it. So, any other questions about detention basins or wetlands? Okay. So this is with my modeling my wetland. You can see that there's some water that's retained in the wetland. Okay. See you later.